Hello everyone, welcome to the today's lecture. In this lecture, we are deep dive into the one of the fundamental topic in Java, that is arrays. In Java, arrays are the objects that are storing the sequence of elements that might be numbers, that might be characters, that might be strings, but they are storing in the sequence. And in this lecture, we will be discussing about the 1D array, 2D array, and jagged array, and we will also discuss the how memory management take place in the different types of arrays, and we will see how stack is storing the references of the each object and how heap is storing the objects. Yeah, let's start with the first question, that is why we need array. We will be having primitive data types that can store anything like characters, numbers, and strings. But what is the need of the arrays in this programming? So let's say if I want to store the 100 numbers or 50 numbers. Okay, let's say I want to store the marks of the 100 students, right? So it's not possible to create 100 variables and store these values. So this is how the arrays can solve this problem. So what arrays does is that this is a single variable, or I would say single object, that can store the any number of objects, right? There is 100 objects, that might be um, like large amount of values, like it might be 10,000 or something 1 lakh values. So this is what the actual array does. So let's see, um, if you want to store the characters, let's say there is a 1,000 characters or 10,000 characters. So it's not possible to create a this many number of primitive data types, right? Char ch1, like you cannot create this number of variables and store these values. So instead of this, we will simply create a character array and we store all those things. So yeah, let's see. So we already discussed, we know that how why we need these arrays. Yeah, let's start with the 1D array. So 1D array is that it's simple, it's a simple box that is storing the elements in sequence, right? Let's say this is a box. So in this we are having partitions, like each partition is storing the one single value, right? And let's say if I am storing 1 year, 2 year, 3 year, 4 year, 5 year. So there is one thing is that they are storing the same data type. Let's say this is storing integer, so if I will put here 2.0, it is float, right? It's not possible to store the different data type. So it's mandatory to store the only similar data type in the arrays. And let's see how we will declare the 1D array in the Java. So initially you need to provide the type of the array you want to declare. Okay, so initially you need a the type of the array which you actually need, and you need to give name of the array. Let's say I'm keeping it as array, and we are creating an object in the heap memory using the new keyword. And I will be provide again type here. So we'll be having some initialization here, like let's say if I want to create array of size 5, then I will put 5 here, right? So this is a basic initial declaration of the array, right? Yeah, it's a array size which is having 5. So it look like something having 5 boxes, so which can store the integers only. And in this array we will be having indexing, which we want to access the element at the particular positions. Let's say I'm having element like 8 year, 9 year, 5 year, 1 year, 2 year, right? So if I want to access any of the element, we will be having indexing. So the indexing is always starting with 0. So 1, 2, 3, 4, right? So for the size of 5, so you will be having 5 boxes. So which is starting from the index 0 and going until the index 5. So this is a basic declaration of the array. So there is another declaration of the array is that you can first declare this array. Let's say I'm declaring array. So after that I can initialize with the size here. So what I can do is array is equal to new int. So let's say if I'm having size 6 here, so I can do this thing also. So there is another way of declaring this array is that let's say if I'm having array is equal to, what I can do, I can directly put the values here, like 1, 2, 3, 4, 5, 6, right? So this is the one way of declaring this array. Yeah, let's go for the code editor, and we will be taking the inputs, and we will print perform some basic operations on the 1D array. Let's say initially I will be taking int n is equal to 10 years, or either you can take the user input from the console. So I will be declaring the integer array. So int is equal to array is equal to new int of end, right? So I will be declared array size of 10 elements. Okay, the next step is that I can either take input for these elements. So every time the indexing of in the array start with the 0, so I will be going until n and I plus plus. I just want to declare the scanner class to take the input. Yeah, this is the scanner class that will use to take the input from the console. So what I can do is that I will be simply putting this array of I is equal to sc dot next int, right? So this is how we'll take input of the integer, and at the each index I am putting the values. Yeah, before that let's put the values manually. Let's say if the 0th index, let me take it 5. So I want to put at the first position 10, and at the second position at the, that would be 20, and at the third position, yes, third position, that is 4. At the fourth position I want to keep element as 5, and at the some, yeah, that's the fifth position I will keeping 6, right? So the one way of assigning values is this is the static way of assigning the values, but you cannot let's say there is some user input data, so you cannot assign these manually. So let's how we'll print in this array. We will be having one of the advantages that if you want to print any of the element at the any position. Let's say if I want to print the element at the index 2, right? So these are the called index. This is called index, right? So if I want to print element at the any of the indexes, let's say if I want to print array of 3, so we can actually print directly without traversing from the starting, right? We can access any of the elements. So this is a best advantage of the array. Yeah, let's see. So what I'm doing is I want to print the element at the second index, right? So you can see that it would definitely printing 4 here. Yeah, you can see it will be printing 4, right? So this is a one way of assigning the values. So, so another way is that I can do one thing, right? So 1, 2, 3, 4, 5, 6, right? So this is a second way of assigning the values into the 1D array. Let's see if I want to, let's say how many elements we are having. We are having 6 elements. So the index is starting from the 0, and it will be going until 5, right? So sixth index is not exist, because you can see that we are having 6 elements. It means that the index is starting from 0. That means we are shifting our coordinates towards the left side. Let's say if I want to print the fifth index value, you can definitely see that it will be printing 6 here. Yeah, you can see that. So this is a second way of declaring the 1D array. Let's say if I want to take the user input, let's say, yeah, let's erase it out. Let's say if I want to take the number of elements from the user, let's say enter number of elements, right? So yeah, I will be taking integer n here. That is this is, I'm taking the n as the number of values that I want to put in into my array. Yeah, I want to declare the array, right? So int array is equal to new int. I will be putting the size here. So you need to specify the type of the array you want, and you need to specify the array name here. And after that, using the new keyword, you are initializing the size of the array. So next step is I want to take the all the inputs from the user. So I will be simply traversing in the loop. So you know that we are having 0 based indexing. So array of I is equal to sc dot next int. I will be taking integer as input. So this is the way of yeah, this is the so this is actually how we can take the input for the array of size n, right? Let's say this might be a thousand size, this might be a 10,000 size, right? So it's not a problem. Let's run it. So we are not printing anything. So let's see if I want to print the array of 5 here. So you can see that we need to definitely have the array size which is greater than 5 here. I mean that you can see that I'm I want to have elements of the size. I want to have a array of size 6. So I'm giving the input as integers 1, 2, 3, 4, 5, 6, right? So you can see that the output we got is 6 because you can see that at the fifth index we are having value 5. So the another thing is that you can do same thing using the loop. Using the loop you can do the complete, you can print the all the values from the array. So let me do print it. I can do array of I, right? So each index, so you'll traversing from the 0th index to the nth n minus 1, and we will be printing all the values at the particular index, right? Let's run it. Let's say I want to take the 5 elements, that is 1, 3, 4, 8, and 9. You can see that we got the output as 1, 3, 4, 8, 9, 5 elements, right? So this is a way of taking inputs and printing outputs. So let's see how memory management and how the internal working is done in the 1D array. You can see that initially we are declaring the array using the new keyword. That means we are definitely having object in the heap, right? So initially in the stack we are only storing the reference. That's, let's say I am declaring an array. Let's say so I'm declaring an integer array, right? So integer array. So that is arr, using a new keyword, that is creating an object inside the heap memory. Let's say I'm providing any size. Let's say it would be n. So this is a reference of the object, right? This was placed inside this stack. So let's say so this was the reference that is actually pointing to the object in the heap memory, right? It would be pointing towards this data, okay, sequence of data. If you got this reference using this array, you can definitely find the reference, next reference easily, right? So they are contiguous in memory allocation. Let's say um, so each integer will taking 4 byte, right? 4 bit, right? 4 4 bits. It means that let's say if I'm having at the second, the next element should be definitely at the fourth, yeah, sixth. So the next element should be definitely at the 10th, right? So next element definitely at the 14th. So this is how we can, you can see that every time this would be taking 4 bits, 4 bits, 4 bits, 4 bits, right? 4 bytes, sorry. So the stack, the job of the stack is that it will be only storing the references of the array. Let's say this is a reference only. So this is having some let's say this is having some hexadecimal value like fx. So this is only the thing which is stored in the stack. So it will be only pointing the object inside the heap. So it is not storing, stack is not storing any of the elements or any of the objects inside the stack. So it is only storing the reference, and this reference is pointing towards the object in the heap, right? So you can actually take out all the elements using the reference. So this is how internally the 1D array is looking something. So yeah, this is how the small diagram which you can actually imagine how internally it is working. So this is the memory address of the array, right? So it will be pointing to the data. Let's say if I'm having n elements, so there could be n elements, right? Yeah, this is yeah, you can similarly you can have array of the any type. So you can have array of the character, array of the, let's say, integer. um yeah, sorry, let's say if I want to declare a array of characters, so you need to provide the data type here, right? So next is char array. You can name anything here. So this is a reference. So we are creating an object of that char array, that is char of n elements. So you can create of the different data types. Let's say you can create for the float, you can create for the double, you can create for the strings also. So the basic definition of the array is that it can store the sequence of characters or sequence of elements of any data of the similar data types, right? Similar data types. So it will be storing similar data types. Let's say if it is an integer, you cannot store any other data to select character or string or any float numbers. So it's an character, it can only store the sequence of characters here. This is all about the 1D array. Yeah, let's see for the 2D array here. So what is 2D array? Let's say there are let's say take a grid of the elements. So there are the five students, each student having five subjects, and you want to store the marks of the five students. Let's say these are the five students. So this is student 1, student 2, student 3, student 4, student 5, right? So if you want to store the marks of all these students in there is a five subject for each student, and you want to store the marks, right? So this is an subject 1, subject 2, subject 3, subject 4, subject 5 here, right? So it's look like something. Yeah. So first student subject 1 marks is, let's say there is some 30 and second subject is 20. We will take random 10, 25, right? So yeah, you can fill all these things. You can see how it work, how it actually need. So this is the solution for the to store these elements. Like for the each student you want to store the marks of the student, you want to store the marks of the second student. So it is the best approach to store all this data. And we can see that if you can take something from the 1D array, for the each 1D array we are creating one new array for the corresponding to the each element, right? Let's say let me take the 1D array here. Let's take this is an 1D array. So this is 0 index 1 2 3 4. So there are five elements, like five places. For each places I want to store let's say 5 5 or 3 3. Yeah, 3 3 now, 3 3 values, right? So this is how you can see that this is how internally to it look likes. It is storing, it's not storing the value here. So you can see that for each in the one, this is an 1D array, right? So in this 1D array, for this value you are actually creating one new 1D array, right? So this is an 1D array, so this is an 1D array, this is an 1D array, this is an 1D array, this is an 1D array. So for each element of the 1D array you are creating one new 1D array corresponding to that element, right? So this part is the 1D array of the separate for this reference. So 0x1 it would be having reference value this one. So 0x5, 0x11, 0x yeah, some you can take something like 15, 0x19, right? Yeah, you can see that. So this is a reference value for the each array. So this is an array. So initially we know that in the 1D array we are having like when you are declaring array, so you are storing the reference of that particular array in the stack. So you can imagine like that. So for each array you are storing all the references in the 1D array, right? So these all the references is pointing the objects inside this for each individual arrays, right? So this reference is pointing toward this array, 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 this reference is pointing towards this array, right? Yeah, that is how the 2D array look likes. And you can see that so where we actually storing the references, right? So let me draw the diagram cleanly. I think you can get more idea about how memory in the diagram, I'd say. So yeah, I think it's not much clear, so I will let me try here. So what actually happens is that So it's look like inside the memory it look like this is an 1D array, right? So yeah, this is the 0, 1, 2, 3, 4. So it is having something 0x, 1x, 2x, 3x, 4x. These some references stored inside this 1D array. For each element or for each index, for each position, we will be having one D array, right? One, two, three, four elements, right? For this yeah, this reference is pointing toward this particular 1D array, and this reference is pointing toward this particular 1D array, right? And this reference is pointing toward this particular array, and this reference is pointing towards this array, and this one is pointing toward this one, right? You can observe that this all these references are stored inside the stack, right? This is an stack, and these are stored in the heaps, right? So all these blocks of and all these individual 1D arrays stored inside the heaps. And yeah, let's see how we can declare we all. So we discussed how the memory management and how the stack and heap stored. So stack is storing all the references of the 1D arrays. So for each corresponding references you will be having 1D array. Let's see how we declare the 2D array here. So initially you will need to declare the data type here. So you need to keep two boxes here, it is square brackets, and you need to keep the name of, you'll be taking it as matrix. And yeah, the remaining thing is the same how you did in the 1D array, same. The extra thing is that we are declaring one of the new square bracket, right? So that would be indicating that for each corresponding array, you are declaring one more 1D array, right? So this would be look like something. So you need to declare number of rows here, number of rows, and here you can declare number of columns, right? You can declare number of columns. Yeah, this is how the 2D array look like in the Java, and we'll also saw how the memory management take place. Let's go for the code editor and let's see how we'll do this one. Initially, yeah, I just want to make it comment here. What I can do is that before implementing something, we will be see how we'll declare it new. Let's say it is in 2D array, right? I will be taking rows has 5 rows into columns has 5 columns. Let's see what is rows and columns. You can clearly observe that these things are the row numbers. Let's say these are 5 rows, and for each corresponding row, you would definitely see that these are the columns here. Yeah, we saw that what is rows and columns here, right? So let's see how we'll code it up. We'll declare the 2D array here, so that is having yeah, I will be taking it as matrix new int. I will be declaring rows and columns here. So it will be, we'll need to specify the number of rows and number of columns here. So yeah, you can assign the values like so the first, there is two ways to initialize the matrix. Let's say the first way is that I will be keep matrix is equal to, let's say inside this I will be having one, let's keep it small, like four elements, right? Otherwise it would be take a lot of time to fill the elements. That is 4, 5, 6, these are 4 elements, right? So in the next thing you can have, I think getting something, yeah, sorry, so we cannot do this. So we can declare the matrix. So one way of declaring the matrix is that you can directly declare using this element here, so without specifying the size of the matrix. um, so right, so another way of, so this is how you can declare the 2D matrix without specifying this size of the rows and columns here. And if you can print it out, you can do a sort of anything, like if I want to print um, element at the row 1 and column 3 here. Sorry, I need to take matrix here. Matrix. Let's see. Um, yeah, that's 4. Let's see. We are printing for the row 1, right? So that is this is in row 1. So we are following one based indexing, right? Zeroth row, first row, second row. For the first row, we are printing the third element. That means the third means we are following zero based indexing. Zero, one, 2, 3. That means 4, right? We are getting right output. Let's see if I want to print it out all the elements using the loops here. You can do that as well. I is less than 4, I plus plus for I into j is equal to 0, j is less than 4, j plus plus. You can do print here. So you can print matrix of I and j, right? um you can do that this one. Let's see, it will be print. We are getting some exception, we are getting output, right? So there is some exceptions, yeah. Let's see that some exceptions like yeah, we are getting right output, right? So in when in the lecture of the loops we discussed that how what is the loop which is running for the rows, and there is loop another loop inside that for each row. That is, let's say this zeroth row you are running for the inside one for loop that is going for the all the columns, right? That is 0 1 2 3. So I think it's already discussed. Let's see how we'll take input, right? So we'll be declaring without size. So let's say declared with this size here. So I will be take row column here. So what I can do is that I will take input from the user itself. So yeah, I will be running loop from I is less than equal to row I plus plus for int j is equal to 0, j is less than column j plus plus. So I out print the, yeah, we'll take input from. So this is as same as that in how we'll take input in the 1D array, but we'll declare two dimensions here, that is row and column here, and sc dot next int here, right? So this is how we'll take input, and you can print using the same loop. I will be copy pasting here, and you can do the same thing, right? I will be printing matrix of ij, right? Let's do it one thing, right? Print. I will be printing new line. Yeah, let's do like we are having 4 rows and 4 columns. You can take these things from the user input also, it's better. Or you can, if it's behave like according to your use cases. Let's say I will be giving input for the first row 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. Yeah, you can see that we'll got the right output, right? So the first row is having 4 elements, the second row is having 4 elements, the third row is having 4 elements. So it's not clear. If I will put space here, it would be more clear, right? So you can either increase the number of columns here. That means that in the each row, so the outer loop is running for the row, right? So this inner loop is running for the columns. Yeah, you may increase the number of columns here, or you can increase the number of rows here. That's not a problem. Yeah, we are doing good. Or you, this is for the yeah, we discussed about the integer. You can whether have character array here, right? Character character array. So the very small bit change we can do here. So the change is that you can simply change the data type of the array you want to use, and yeah, we'll be having something. There is a, yeah, you can change these things like input, how you'll take input, and you can, yeah, these other things will remain same. So you can need to change this inputs and outputs. You can either have string here, right? You can either have string also. Let's say and you can change these things, so everything will work well. Yeah. Let's see, there is a last one, that is a jagged array, right? So, so in previous thing we saw that for each, let's say there is five students, if you want to store the marks of the five students, you need five columns, right? Let's say there is some cases, in some cases that the first student is if I want to store the details of the what I can take yeah. So I will be taking student 1, student 2, student 3, student 4. So I just want to store the specific number of, let's say the student having 3 subjects, the student having 4 subjects, the student having 6 subjects, the student having 5 subjects, right? So you can see that the columns are not consistent here. You can see that the columns are variable here. So this is the case we can how you can do using the 2D array, but you can it's take more space. Let's say if you declare the 2D array, you will definitely declare all the columns should be 6, but you are not required the 6 columns here. You are only required 3 columns, right? So let's see how we are consuming more space in the 2D array. So the memory management will be remain same as like 2D arrays, but there is a small change in the declaration. Let's say I will be having 5 students, right? So the student 1, student 2, student 3, student 4. So this student is having only 3 subjects, 3 subject S1 S2. Let me try it clearly. This student is having 3 subjects, that is S1 S2 S3, right? And this student is having 4 subject, 4 subject, right? That's it, that is S1 S2 S3 S4. And this student is having like, that might be 5 subjects, right? So this student is maybe having 5 subjects, right? S1 S2 S3 S4 S5. The student is having only 2 subjects, right? S1 and S2. You can see that so you can do using the this is a memory address 0x0x0. This is an address, memory address of the each array. So this arrays are considered as a 1D array, right? This is an 1D array, this is an 1D array, this is an 1D array, this is an 1D array. So you can do it using 2D array. Let's see, if I want to declare, I can declare all the columns as size 6, like let's size 5, right? So that would be maximum size I can do. So for the student 1 and student 4, you can see there are a lot of boxes which are remain empty. You are not using these boxes, these boxes, these boxes, these boxes, right? And it's more memory consumption. So what if we can do something like let me erase it out. So what I can do is that I just I will declare the each 1D array according to their requirements. Let's say this student is want array of size 3. This student is want the array size of 4. This student want array size. I can do these things, right? So I can have all the references. So for each reference, I will be having 1D array that would be a specified size. Let's see in code editor how we can do this one. So I will be commenting it out. Third thing is jagged array, right? Let's say so the declaration is chain bit live. So for each array we'll be having some 1D array. So we'll be having some differences in the, I will be declaring it as array only. New int. So you need to specify number of students or number of rows you actually want. So you need to specify this size in the number of rows, but you can have exception that you can actually after you can have declare initialize this size of the each 1D array after declaring this, right? So I need to definitely declare this size of the number of rows you want. I want 5 rows. So I don't know the actual number of columns for each student, right? Actual number of boxes, or I would say number of kind. Yeah, what I can do is that I can do one thing, that for the first, let me declare it as 3. It would be more lengthy. For the zeroth row, for the first column, I will be declare new int, sorry, array of, so that is zeroth row, and that is zeroth column, right? So I want at this place the number of elements should be, yeah, I want yeah, for this index, for the first zeroth row, I want the number of elements to should be 3, and for the first or second column, I want elements as 4, and array of 2, I want the number of elements to be 5, right? So we're done with the 3 rows. We have declared the 3 rows here, and you can take input, or this is a simple initialization of the jagged array. So the next step is you can take input, or you can put the values by manually, or you can do anything. So we created something, it's look like something that we created some containers such that it can store information of the 3 student, that is 0 1 2. So for each corresponding indexes, we created one 1D array, right? So that would be initially, the initial array is having 3 4 5, right? So yeah, the first array is storing 3 elements. So next array is 5 elements, 5 elements. Next array is storing the, sorry, 4 elements, right? Yeah, this array is storing 4 elements. So you can see something inside the system. We created something like this. We are not initialized anything, right? So for the each corresponding indexes, we have created one 1D array of the different sizes. This is called jagged array. The one way of assigning the values to this jagged array is that you can do assign values using manual, like one for the first zeroth row, you can, for the zeroth column, you can declare the values like 4, or you can do you can fill all these values like using manually. So the another way of assigning value is that using the loops. For int I is equal to 0, I is less than 3, I plus plus for each row. So you will be having corresponding one day array, right? So there is, we will be having into j is equal to 0, j is less than array of I dot length I plus plus. So the length function in the array is that used to tell the size of the array, right? So the length function in the array will tell the number of elements in the array. Let's say if I want to find the length of this particular 1D array corresponding to this index, so what I can do is I will be do array of I dot length. That means that it will give the length of the 1D array that is corresponding to this particular index. So that is what I am doing here, and you can assign the values like this, and you can assign like, I will be assigned like I place there, or you can assign any values. You can print out the all the values using these loops, right? So or you can take the all the values from the user input also as well. So these are the basic operations, and the fundamental things you should definitely know in the arrays. So yeah, let me print it all these things here. Yeah, just copy paste it. So I will be do a south print for the array of I, right? Array of I, j, and s out, right? Let's see what does it will print. We're getting some error index. Okay, let me check. Yeah, we are going go to go now. Yeah, so we are having three indexes. We are having array of by dot length. Okay, okay. Sorry, we are did I place we need to do j here, right? Yeah, you can see that we are getting right output. So you can practice with all the different data types, right? So I think we'll done with this all this. Like, let's wrap up all these things what we have discussed in this lecture. So initially we learned what is a requirement of the array, and what is how the memory management take place in the array, and we discuss all these things, like so how to traverse and how to take input of the for the 1D array, 2D array, and you can do with the all these different data types. Thank you for watching.